Okay, this one should have frozen by now and should be safe to pull out. Hello. Okay, so as you can see, I've been a bit busy today. All of these used to be machine castings on the left here. We had a table saw, we had a scroll saw of unknown brand. It was a very high quality saw, but we ended up scrapping it. And I've got a really old 7-inch angle grinder here that's going to be added to the mix. Okay, all of this is siliconized aluminum, because which is aluminum alloyed with a silicon metal, which gives it this distinctive sort of smoked gunmetal-ish darker gray color. And what the silicon does is it allows it to flow better into molds, which is why you probably can't tell from this far away, but these have some very clean lines in them because they were some really high quality molds. And I think this will help me out too. On the right, what we have is aluminum extrusion, as we're all familiar with on this channel. This does not have silicon added to it. It needs to hold shape rather than flow, and it's basically what you find everywhere. Now this is more pure aluminum than this is, although there's probably a bunch of impurities in there too, who knows. And so each of these two things have their uses. I will be doing all of the machine's castings, final castings, out of this stuff, because this is what it's meant for. So first thing I got to do though with all of this is that I got to turn it into an ingot. Now, I have a very precise way of processing aluminum casting. As you can tell, absolutely meticulous. And similar methodology for our extrusions. Anyway, they'll all fit in the crucible, they'll all melt, they'll all go into a pie pan, or muffin tin. And then they will all be poured into a new casting, except for these. These will end up in a casting too, but I have something in mind for them. Now I have a test casting I did versus a professional engineering sample, and you should be seeing it in footage right now. The industrial has a much finer grain structure than my own. They've got now this is a different alloy cast at a probably higher temperature in much better molds than mine, without the interference of charcoal and a bunch of hot air. So you know, I really don't know what anyway, but what I will say is that theirs broke easier than mine did. Okay, now what you're seeing here is what I didn't really want to see. Okay, if we zoom on in, alright, this is the new furnace. It is behaving unfortunately just like the old furnace. And this material, which is essentially just an earthen oven, it's the cheapest clay available, that would be bentonite, in the form of cheap cat litter, and play sand, and water. And those are the three ingredients, well, plus some natural fiber rope. Now, just to try to hold it together. Now this thing is showing signs of one use. It's showing signs of heat erosion. It's cracking. It's gonna fall. It's gonna fall apart, and it's gonna need constant reapplication of the DIY, the cat litter refractory, to keep it going. Now what I'm gonna do now, luckily, this time around I came prepared for this. Okay, so what we're doing today, we have these little bags of a commercially available refractory that goes by the brand name, and my hand to God, Satanite. It's rated for 3,000 Fahrenheit, and since the highest temperature steel I know of melts at 2,800 Fahrenheit or thereabouts. This stuff will get the job done. Now, the way this stuff works is it goes on in thin coats. You mix it up with enough water so that you've basically got a peanut butter consistency. And then you smear it on and you let it dry overnight, and then it needs a heat cure. So you can do that with a torch, or you can light in my case, I'm going to be lighting a fire in the thing, and we're going to get the bottom sides and the underside of the lid coated with this. And what this will do is make, in addition to stopping the heat erosion, hopefully, of the base material in the furnace, it'll also add efficiency to it. And I'm not done there, because after we get this thing sorted out with that, then because I don't really want that, I have one other trick up my sleeve. Then we're going to use this 100 HT, which is a paint-on ceramic coating. You mix it with water until you get a paint, and then you paint it on. Self-explanatory. And that by itself will then reflect the infrared heat generated by the fire, which will increase the efficiency that much more. And the reason I'm doing this is because I am tired of having to pull the crucible out to add more charcoal. So any amount of heat I can get this thing to reflect back into the material hopefully melts before I have to refill the fuel. So anyway, fun stuff. Okay, thought you should see this. I'm at what is, I finally, took me about 20 minutes, but I tracked down the line of code where we lost the Z height. Now, this is a very teachable moment. If you look at where I'm moving the cursor, down to here, this file is 98% finished. Right, see this where it says adaptive 13? Yes, that was an adaptive clearing operation for for this triangle right here. Or maybe it was that one. I can't remember. Anyway, point is, it was the last triangle in the thing. There were 13 of those that had to be cut out in this fashion. and it does, and that was all the G code that it had to set up to run that. The next operation is is basic profile, is helixing a bunch of little circles for a thing, and we're gonna do that right now because I can run this G code from a line. So I'm gonna start it up to run it again from a very specific line. Let's see, what is this? No. This is very dangerous, but I'm gonna do it anyway. Well, so far it's working. Okay, now as you can see, the job is running right now, and we are cutting white packing styrofoam, which I think I got on an Ashley Furniture assembly gig. Now, there's certain things you have to remember when cutting styrofoam. You can pretty much, there are specific plastic / foam cutting bits, but quite frankly, regular bits seem to do the job perfectly adequately. The things you have to worry about are proper RPM and movement rate, i.e. feeds and speeds. Right now I have this is a Makita RT0701C router. Alright, I've got it on number 2 setting, which is about 10,000 RPM, give or take. The movement speed I have dialed in is, well, I've got the specified in the job, I've got it at 300 millimeters a second. Very quick. This stuff will do two things. It will generate an insane amount of static electricity, and two, it will melt. And when it melts, it coats the bit. So you have to keep things moving fast enough to avoid generating heat in any one area. And if you're wondering why these, because I had to film this, I couldn't use the dust shoe. And that looks like the whole casting. Now you want to be careful, because these things are still hot enough to boil water. That is about as good a casting as I could have possibly asked for. Okay, so that melt probably went as perfectly as any melt I'm ever going to do is going to go. We got our first perfect casting, and this is a perfect casting. Okay, you should be seeing right now footage of the close-up footage of the surface detail. This is, I know it looks ugly, and that's the point. This was white styrofoam, and the wallboard mud actually basically seeped into all the little pores, filled them all up, and I got perfect surface detail transfer to the casting. So, and there's no sand in it. So I could not be happier with this. This is exactly what I wanted. This is exactly what I've been envisioning since I started this methodology. And we finally have it. This is our part. This is our first finished, well, it's not finished, but this is our first perfectly successful casting. There's no flaws in this casting that I can tell. Unless there's voids, you never know. Won't know until I take a hacksaw and cut this and cut this. And FYI, this is not waste. These pieces, once they're severed, they're going into the bin and they're going to get melted down again and poured into something else. So yeah, this basically couldn't have gone any better. And what I used was this white foam to finish off this, kind of clean it up. This is a sanding block with 60 grit sandpaper. Cheap, absolutely cheap craft special hot glue gun. Razor knife. You know, that's it. That's all I got used. So, yeah. I'm pretty stoked. This is going to work. So remember, if at fourth you don't succeed, try again. And eventually, you just might get there. So, that's all I've got for you this particular installment. God bless. We'll see you in the next one. Ciao.